Hey everyone, welcome back to our channel. Today we're going to write 0.12727 continuing as a fraction. So for this problem, there are two methods. First is the classic method, and that's what I call. So solution 1, solution 1. So for this, we are going to pretend that 0.127 continuing equals x. So that equals x, and then after we are going to times x by 100. So 100x equals, we move the decimal 2 places over, which equals 12.727 continuing. So now that we have these two, we have to subtract x from 100x. So 100x minus x equals 99x, and that also equals 12.727 minus 0.127.
Don't forget the line.
Oh yeah. We have the lines. Okay, now that we have this, we can separate it to make our lives easy. So we can see that they both end in 27. So we are going to separate it. So it's going to be 12.7 plus 27. No, wait, not 27. It's plus 0.27 continue minus 0.1 plus 0.27 continue. Okay, we can see that they all have 0.27 continue. So since
it should be 0.027 continue.
Oh yeah. Okay, since it's that, there's two of the same things, which means we can cancel them out. So if we cancel them, then at the end, this will equals 12.7 minus 0.1, which equals 12.6. So this equals 99x. So we have to find what x equals. So we have to divide both sides by 99. So then x equals 12.6 over 99. And then we need to make this fraction look beautiful, which means we need to remove the decimals, which means we have to times both sides by 10. Okay, now we have this fraction, but we need to make it look...
It should be 990.
Okay, so since we have this fraction, we need to make it look simple because we like simple stuff. Math always needs to be simple. So then we could simplify this, and it will equal... Let's see over here. Okay, we can first divide both sides by 2. So 61 over... Wait, what does that equal? No, wait, no. It's wrong. Okay, so we need to simplify this. So we could divide both sides by 3. 42 over 3, 0. And then we could divide both sides by 6, which gives us 7 over 55. So this is the fraction to that number. There's also a second method. So we'll divide this. Solution 2. So this method is going to involve an infinite geometric series, like the sum of it. We're going to turn it into one of those. So we have the number 0.122727 like that. And we can see the first part, 0.1, it equals 1 over 10. And there's going to be add. And since we have that, so it can be like 0.1 plus 0.02. And that, we know it equals 2 over 10 squared. And if we continue on the pattern, it can be plus 0.007, which is 7 over 10 cubed. And we can continue it like 2 over 10 to the power of 4, blah, 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 all the way down. So we have this, but this isn't really a geometric sequence because if we divide these two numbers, it does not, if we divide like 7 over 10 cubed by 2 over 10 squared, it will not equal 2 over 10 to the power of 4 by 7 to the over 10 cubed. And 1 over 10 is not part of it because the numerator is not just part of like the 2727 pattern. So to turn it into the same, we need to turn the numerator into the same number. So in order to add the two numbers up, we need to turn the denominator into the same. So for this fraction, 2 over 10 squared, we can times both sides by 10, which will equal 20 over 10 cubed. And now we can add it up to 7 like that. And we can turn that into that plus, and then it's on and on and on.
10 to the power of 5 or 2 to should be 20.
Okay. Okay, we have this. And that we can simplify it into 27 over 10 over 3 plus 27 over 10, 5, on and on and on. And that we are going to leave to the side for later. We're leaving it for later. So whenever we see these things, we need to find the common ratio as always. So we have to divide these two sides. We need to divide this by that, which will give us 1 over 10 squared. So now we can use the formula for an infinite geometric series, like the sum of it. And the formula is the first term, which is a, over 1 minus r, which is the ratio. So we can bring in the numbers for the formula. So it's 27 over 10 cubed over 1 minus 1 over 10 squared. So we have this, and we can solve the bottom part, the denominator, which is, 99 over 10 squared. So now this will equal 27 over 10 cubed over 99 over 10 squared. And if we solve this, this will equal 27 over 10 cubed times the reciprocal of the denominator, which is 10 squared over 99. And we can cancel, so this becomes 1, and this becomes 10. And that will equal 27 over 99, 0. And we can simplify it because we like simple things, which is, we could divide both sides by 9, 3 over 1, 1, 0. So we have the answer right here, but we're not done yet. we need to add the leftover, which is 1 over 10. So we have 3 over 110 plus, we could turn the denominator into the same by times the top and the bottom by 11, which is 30, no wait it's not, which is 11, 110. And this will equal 14 over 110. Now we have this, we could divide the top and the bottom by 2, which will give us the same answer, 755. So these two answers are the same, which means both of these methods work. Honestly, the method I think was the most interesting was probably the solution 2, but you guys can have your own opinions. Please write down in the comments which method you like better, solution 1 or solution 2. Thank you for watching. Bye!